Welcome back, friends. Ms. Pariseau here to kind of do a little bit of talking about exponential growth and decay type of problems. And so, but more specifically, like percent growth and decay. So we've already talked about, again, just as a very, very quick recap, we've already talked about that basic format of an exponential function. All right, so we're going to take a look at those here. Let's just take a look. We've got table values. And as we see, as our x values are increasing, we want to pay attention to what is happening to our y values. Well, we went from 300, 306, so we can see that they are increasing. All right, and it might look like, well, we're adding 6, and then we add 6, but then we don't quite add 6 again. It's close, but not enough. So instead, we want to think, if we're going to think about this exponentially, all right, let's think about, is there something that we're multiplying by? All right, so let's say 300 times what is going to give me 306. So, right, we can go ahead and do 306 divided by 300, and we get 1.02. And so that means that if I multiply 300 by 1.02, I'll get to 306. Well, let's test that out. What's 306? 306 times 1 and 200, so 1.02. And we get 312, and it's technically 0.12, but it's close enough. All right, and then let's go ahead and do that again, times 1.02. And we can see this if we take a look. I'm going to go ahead and do that in my calculator here. Quit out of that. All right, so again, we did 300, and if we times it by, we found that we multiplied by 1.02, right? There we get 306. All right, let's do times. Let's do that again, like we're continuously multiplying by the same number. Okay, we get 312.12. If we round, it's 312. All right, and then if we multiply it by 1.02 again, we get 318.36. So let's just take a look at our table, 318.36. And so we can see here, we got a good idea, like that is our rate. And again, if I were to do times 1.02, I'm just keeping it in my calculator, no rounding. 324.72, which rounds to 324.73, which is what I have here in the chart. So I can see that my factor, or my rate, right, aka my rate, is 1.06. Now we're calling it a factor instead of rate because it's something I'm multiplying by. It's something I'm repeatedly multiplying. And we can see that it's a growth, okay? And I can also see here's my y-intercept when x is 0. So if I wanted to go ahead and write an equation, I could, right? It's 300 times 1.06 to the x. And so now I could go over to my calculator and I could put that in and say, okay, if I want to know what it is to the 10th power, right? So I'm going to do 300 times 1.02 and to the exponent, 10th power. I'm going to hit enter. And we get 365.698. So everything else is rounded to the hundredths, so we're going to round to the hundredths. And we get 365, and I've already forgotten the number because I have a Dory memory. 0.70 is what it's going to round to. Okay? All right, so something I want you to notice is what we are multiplying by. We're multiplying by 1.06. Okay? And then the other thing, let's take a look now at the next one. We're going to do this exact same thing. Right? How did I get from 32,000 to 29,440? So again, all I have to do, if I want to find the rate, yeah, I could set up the whole equation. 32,000 times what gives me 29,440. Well, I can already see I took something big and I went smaller, so this is obviously going down. It's going to be a decay, right? But essentially, if you're going to find your factor, or aka your rate, we can just go ahead and do take the next term and divide it by the previous one, right? Because that's what we would be doing if we were setting up and solving an equation. Okay, so we're going to go ahead and put that into our calculator. We're going to go ahead and do Dory brain coming back. 29,440 divided by 29,440 divided by 32,000. There we go, and hit enter. We get 0.92, all right? Okay, so that means that it looks like if I multiply by 0.92, I'll get the next successive term. And so we can put that into your calculator and test it out, and we'll find out that it does work. So I'm constantly multiplying by 0.92. Now notice what's happening, right? Notice what's happening. It's going down. These values are going down. And again, think about that factor. Think about that factor. If we were to write our equation, the y-intercept is 32,000 times 0.92 to the x. And we could go ahead and plug into the 10th power, and we could get our value there. Okay? Now, something I want you to think about is, and we'll go here and kind of taking a look at these types of problems, very, very similar, right? I want you to think about, let's actually start with number 4, because it's easier to kind of wrap our head around. All right? This is like these are going back to percent problems. All right? We've got a pair of headphones that cost $250. They're on sale for 30% off. Well, if I was to go ahead and figure out, okay, well, how do I figure out how much money am I saving and how much money am I paying? Like, what's the cost of these headphones? Well, I have a couple of different options, right? If it's 30% off, right, I could go ahead and say, well, 250, and I could go ahead and multiply it by 30% or 0.3, right? And when I do that, that's going to actually tell me, oops, 250 times 0.3. All right, that is not the price that I'm paying for the headphones. That's the price, because remember, this is how much we take off. So this is how much money is going to come off of the cost of the headphones. So now I'd have to go back and say, hey, 250 minus 75, right? And so then I would figure out, okay, well, here's the new price that I'm paying is $175. Right? So that's kind of like, you know, if we throw back to 7th grade math with percentages, that's what we'd be doing. Well, let's take a look at it a different way. Okay? Now let's take a look at what we were doing before. 250 to 175. What can I multiply 250 by to get to 175? So in our calculator, we're just going to go ahead and remember we do that math. 250 times what gives you 175? It means that we're just going to go ahead and divide those numbers. And we see that we get the factor is actually 0.7. So I want you to compare. Look at this number here, 0.3, compared to 0.7. Right? This number here, right, 30% was what was taken off. So that is the discount. What did we pay? We paid 70% of the original price. And the reason that that's important is, notice we didn't multiply. To get to the new price, we had to take 30% off, and then we'd subtract it and go from there. We could have just said, hey, I'm not buying the whole thing anymore, the one whole. I'm taking off 30. And 100% minus 30% is that 70%. So there's where that factor is coming from. Okay? And this, we're not going to worry about an equation. All right, but notice that this was a percent decay. It was a 30% decrease in our price. It wasn't a 70%, right? It doesn't look like that factor anymore. So we're starting to see that the rate or the factor is not necessarily, does not equate itself to the percent growth or percent of decay. All right, and so when we're talking about that is, again, it's this idea, and I'm going to switch over to the official notes because this was just kind of getting into this idea about if this were to increase every time, right? Well, let's go take a look at number 5, okay? The original price in 1995 was $4.35. Okay, every year it increases 6%. So again, I could go through, if I'm completing this table, I could do $4.35 times 6%. But that's just going to tell me how much it's increased by. And then I have to go and add it. So instead of doing all of that, I can, if we understand percentages, if it's increasing by 6%, I'm paying 100% plus 6% more. So what does that equal to? That's 1.06. Okay? And so just to kind of show you the math behind that, just to show you that it does work out, right? If we take a look, $4.35 times 0.06, right? If we're doing that, we're finding what's 6%. So that means this is how much our price has increased. So if we add that back to the original, All right, we get $4.61, right? We don't need that last place value because we're talking about money. All right, well, now let's take a look. What would have happened if I just did $4.35 times 1.06? I get to the same answer. So the reason that this is helpful to understand is that now I don't have to go and like, okay, here I found the new price. I got to find 6%, and I got to go back and add it. Okay, so if we understand that we're increasing it, we're paying over that original price. We're paying 100% plus 6% more. Now I can go ahead and fill out. So here I can take $4.61 and I can multiply it by the factor of 1.06. Right? And I get my new price, and if I'm rounding to the hundredths, it's $4.89. And I can keep doing that. Okay? So $4, and then we're going to do $4.89 times our factor, and we get $5.18. $5.18 times our factor is $5.49. Okay? So again, take a look at our factor. Our factor, aka our rate, is 1.06. However, our percent of growth is 6%, right? That's how much it increased by. So we have to think about this in terms of how it relates to one whole, okay? And so if it's increasing, it's going to be one whole plus that amount. Well, if we take a look at the price of a car, okay, cars depreciate or they lose their value, and it's on average about 8.5% each year. Okay, so if we take a look at that idea, let's see what that looks like in the table. So it starts out at $47,000. Okay, so here's the thing. We're decreasing it by 8.5%. So it's no longer worth its full value. So that means I'm decreasing. It's lost 8.5%. Think about like on a test, right? You missed a certain percent of the questions. You take that away from the 100 to see, okay, what percent did I get correct? And so here we find out like, okay, here's what's left. Here's the value. Here's what it lost. It lost 8.5. So it's a percent decay, right? It lost is 8.5% loss. And what does that mean our factor is? It's not 8.5. It's not a negative 8.5. It's going back into those terms of we had one whole minus 0.085, right? And we can think about it that way. It's 91.5% or 0.91. Look, that's on the 1.5. So that means that I can either, the reason I'm doing that is I'm going to do 47,000. So again, I can go over to my calculator. Okay, I can either do 47,000 and I can times it by 8.5%, which is 0.085, right? But that's just how much the value I've lost. I have to now go and subtract it from the 47,000. 47,000 minus 3,995. Whereas if I could have done it all in one step, times, well, not 0.085 because I want to know what's left of that. So it's 915. And I get the same value, okay? And that's an important feature. That's actually how we write these percent of growth and percent of decay, is that if we know how much it's growing or decaying, we're actually always going to relate it back. It's either, if it's a growth, it's 1 plus the rate, and if it's a decay, it's one whole minus the rate. And if you take a look at that, right, that's how it's working out. So that's something to think about as you work through these problems, is we can create these formulas from this, right, but it's not using the given percent. We have to understand how it relates to the whole. Where did we start? How did we begin? So hopefully that helps you get started on understanding percent growth and percent decay problems.